Hello, and welcome to 5 Minute Math. Today we are looking at the 5th grade mathematics STAAR test from 2024 and trying to learn some lessons from the readiness standards in which we struggled with. And these are the readiness standards we're looking at across the state of Texas. Any readiness standard in which we scored below 60% of proficiency or mastery, we're going to take a look at those items and see what kind of lessons we can draw from them, both why we got it wrong, and what are some instructional implications. So, the lowest performance readiness standard for this year, 2024, is 5.3K, which is in reporting category 2, 32% overall mastery. It was just one item, number 12, but you see it was text entry. There was no ABCD. We just had to use the equation editor just to enter in the answer. We had only 22% correct. We had to add and subtract rational numbers fluently. And you notice here we've got a decimal, and then I've got two fractions. So that's something that's a little bit new for some of our students. Might have thrown them off. Now, there are a few different ways we can do this. Probably one of the easiest ways to do this would be to think about this 0.75 and try to convert that into a decimal or a fraction. And I'll tell you why in a second. If we can think of 75 cents as 3/4, then we should know that 75 cents or 0.75 or 75 hundredths is the same as 3/4. Now, that helps because I've already got a 1/4. So if I can realize that 1/4 plus 3/4 equals 1 whole, so Monday and Wednesday equals 1 whole, 1/4 and 3/4, and then I've just got 1 whole plus 5/8. So students could have entered 1 and 5/8. If they wanted to, they could have changed everything to a decimal, right? So what is it? 1/4 is 0.25. I've already got a 0.75. But then I've got to do the 5/8, right? I've got to divide up because that's not necessarily a fraction we've memorized. And that's 625. And then you also could have just entered 1.625. That also would have worked as well. So this was definitely difficult for our students, not only adding the different modes of form or the different versions of forms, but then just using the calculator here to enter in the answer, especially this mixed number might have been a little bit difficult. So we had to add fractions and decimals. That's what made it so difficult. Like I said, we could have converted that 75 hundredths to 3/4 for easy addition, but they need to be given opportunities to practice that. And really, what we're talking about are benchmark fractions and percents that they start to memorize in 6th grade. Well, this is the 5th grade. They can go ahead and start memorizing those. Students shouldn't need to use any type of conversion to know that 1/4 equals 0.25 or 3/4 equals 0.75 or 1/2 equals 0.5. These are things that they're going to need to know again and again and again. In 5th grade, we might as well teach them to memorize some of these. And that equation editor definitely added rigor to the question. So what can we do? And you're going to see it in the white text at the bottom here. We can practice converting fractions and decimals. I think adding decimals was not necessarily difficult. It was the conversion. So this is the difficult part, converting fractions and decimals. But for 5th grade, they're going to be fairly easy. Now that 5/8 wasn't so easy, so we need to practice that, right? That's your long division. You go 8 into 5, and you would have got the 0.625. Now, they need practice with that, and then let's get into some of those benchmark fractions. Like I said, it is 6.4F. It's a 6th grade standard, but some of these are going to be very easy for students, and they can pick it up in 5th grade. There's no reason why they can't do it now, because as we can tell, they're going to need it. Next, 5.4B, which is a readiness standard in reporting category 2, 32% overall mastery. Only one item here. We had to represent and solve multi-step problems involving all 4 operations. Now, here's the tricky part. Jeremy has a string that is 84 inches long. All right, so that's my total. So since they give you the total, let's go ahead and put it up here as the total. He cut 4 pieces of string that are each 18 inches long. Then which equation can be used to find z, the length of leftover string? So you see here, I've got 5 pieces, and that's the tricky part here. Okay, so I've got 5 pieces. These four pieces are each 18 inches long, but it says I've got length of the leftover string. So I'm going to have Z as my leftover string. So the 18, because look, 18 times 4, right? Hopefully our kids did this. That's only 72 inches, so it's not the whole thing, right? So that means this is going to be 12 inches. Now, which of these can be used to find 12? That's where it gets tricky, okay? Well, you notice that we need to multiply 18 times 4. We don't need to add 18 times 4, so that's not going to work. But then what do we do? 84 equals 18 times 4 minus Z? Well, if this were on this side, right, maybe we could use a subtraction. But 84 equals all four of these. Look at my strip diagram. Plus my unknown. So my answer here is C. That was tricky. 32% because I had to take my 4/18s and my Z, all that added together, got the 84. So this equation was written in reverse order, right? They had the 84 equals. That might have thrown some kids off. We had to correctly interpret this leftover as addition because sometimes in context it can mean subtraction. So that's where it gets tricky here. And then more students chose A, 35% than the correct answer. Let's go back and look at A, right? The core pieces are the same. They were just thinking, oh, leftover means subtraction. Well, it might mean subtraction in certain contexts. That's why we have to draw pictures or strip diagrams to see, oh, look, I'm adding all five of these pieces, the 4/18s and the unknown Z. So draw a strip diagram. If you can represent the relationship, what's going on in the story, you can easily see that you're supposed to add rather than subtract. And then have them solve for the leftover string and substitute in Z to check for their work, right? So if I know that Z is 12, and I know that 18 times 4 is 72, right? Look at A. I can now say 84 equals 72 minus 12. No, that doesn't make sense. That's going to make 60. Actually, 84 is going to equal 72 plus 12. So if they can go ahead and just figure out what those 4/18s equal, they can use a little bit of substitution and see if A makes sense, which in case it doesn't. Next, we're looking at 5.5a. This is a readiness standard in reporting category 3. Only 45% overall mastery, but this was tested twice. We're classifying two-dimensional shapes using some type of graphic organizer. So on number 7, we've got, the graphic organizer is just a table. Really not much of a classification, but it still tripped our kids up. Where should we classify this triangle? Here's the angle we need to be looking out for. This is an obtuse angle, which means this is an obtuse triangle. So a triangle with one obtuse angle is an obtuse triangle. Okay? A triangle with one right angle is a right triangle. And then acute has to be all three acute. Equiangular, which we don't use that often, we typically call them equilateral, but it's the same idea. Those have to be all three equal. And you'll notice our answer here of C, but only 41% of our students were able to get this. A lot of students are going to choose acute because both Z and Y are acute, but 2 out of 3 doesn't work. The third one needs to be acute in order for it to be an acute triangle. Now, 49, we've got your traditional Venn diagram, but take a look. We're looking for a shape that belongs in group 1, but not group 2, so it needs to end up over here. So it contains at least one pair of congruent sides, but it cannot contain at least one pair of parallel sides. So we need to draw some pictures here. So I've got my square. It does have congruent, so I'll put C for congruent here and P for parallel. It does have congruent, but it also has parallel. That's a problem. Isosceles triangle, right? So here's my isosceles triangle. It does not have parallel, but it doesn't have, it does have pair congruent sides. Okay, so that does work. All right, so it could be B. trapezoid. Trapezoid's kind of weird, right? So you can draw a trapezoid like this, and you definitely have parallel, and you maybe have congruent. These two sides are congruent, but if I draw a right trapezoid, I'm going to get the parallel, but not the trapezoid. So I'm not sure about where that lands. But either way, it's group 2, so we don't need it. And then a scalene triangle is just going to be 3 of different lengths, and it doesn't land anywhere, right? So our answer here is B, the isosceles triangle. But you notice the vocabulary. Isosceles, scalene, they can need to be really solid with these classifications of triangles. All right, so for number 7, the first one, more students chose A, 45% than the correct answer. So 45% of our students chose A as opposed to 41. Once again, we're just looking at these two angles, seeing why they didn't correctly classify X as an obtuse triangle, an obtuse angle, or if they did, they didn't realize that one obtuse angle makes the entire thing obtuse. That's the trick. For number 21, the correct answer was not in the middle. I think that might have messed some students up. Usually, we're used to finding answers here, right? Find something that belongs in both groups. So that could have been square, that could possibly have been a trapezoid, depending on which one you drew. But it was not in the blank. We had to find group 1. So we need to help our students solidify those definitions for types of triangles, both on angle. So you've got the right triangle, the obtuse triangle, the acute triangle, and now we need to add equal angular triangle. And then on sides, right, we've got an isosceles, a scalene, right? We've got equilateral. We we need to help our students just practice those again, again, and again. And then Venn diagrams here. Have students work with these Venn diagrams, give them a whole bunch of shapes, and have them find shapes that fit in all 3 areas, the overlap and then each individual area, rather than just sticking with the overlap. That will give them some flexibility so they can tackle these types of problems in the future. All right, 5.3L, we are looking at reporting category 2, 49% overall mastery of dividing whole numbers and unit fractions, some of our favorite standards in 5th grade here. So we did okay on number 17. 60% correct. We're pretty happy with that. Area is 3 pies. Each pie was cut in equal slices. If each slice is 1/6, look, I can draw 3 pies right here. And some of our students might have done that. So you kind of draw a fat X to get the sixths. How many slices do I have? I got 6, 12, 18. So what I did is I did 3 divided by 1/6, which is the same as 3 times the reciprocal, and you're going to get your answer of A. We did that okay. Now this one was a little bit more difficult because it didn't have that visual of the 3 pies. Number 25. Trisha runs around a track. The distance of 1 lap around the track is 1/4. She runs a total of 3 miles. Now, if you wanted to, you could do the same thing, right? You could visualize it as 1 mile, 2 miles, 3 miles, and she's running 1/4 segments. So there we go. Now, the difference is I've got to put the entire thing in here, right? So if those are my 3 miles, now another way to do it would be to look at it on a number line. There's 0, there's 3, there's 1, there's 2, and I need to know that I am running 1/4 miles. So how many sections are there? Well, if I'm counting the sections, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Either way, your answer needs to be 12. What did I do? I took my 3 holes and I divided it by 1/4. Now, this is a 2-point problem, so you had to get both of those correct to get 2 points, and you got half credit if you only got one of those 2 correct. So that one obviously was a little bit trickier. So they didn't necessarily struggle with the multiple choice item. They definitely struggle with the drag and drop, identifying the division of unit fractions. And you notice they gave them the 3 and the 1/4. All they had to bring down was what's the operation, and then what's the answer. So for students that struggle to conceptualize the correct operation, have them perform both and then check for reasonableness, right? So if we were struggling with that 3 divided by 1/4, I know my answer needs to be 12, 3 times 1/4, right? Well, we know that 3 groups of 1/4 is going to equal 3/4, because that's really just 1/4 plus 1/4 plus 1/4. And that doesn't make sense because she was supposed to have run 12 miles. So this is where you realize, okay, 3 divided by 1/4 is the same as 3 times the reciprocal, or 4. And so have them check both. Do both and just check for reasonableness to see if it makes sense. And then a lot more of the student practice problems as we're working with this should be more open-ended. Just write an equation rather than multiple choice, because multiple choice sometimes becomes multiple guess. We don't know what they actually know. So give them opportunities for those drag and drops, more open-ended with paper and pencil. So next we're looking at 5.4F. This is reporting category 1, 50.5% overall mastery. We're simplifying numerical expressions and 2 different types here, right? On this first one, it's just a full simplification, okay? So looking at order of operations, we need to do those inside parentheses first. So we need to have 5 times 2 makes 10. Now I can do next this division. 20 divided by 10 is 2. So now what's left within this bracket is 30 minus 2. That's 28. And so now I've got the 2 times finally. So 2 times 28 makes 56. But 2 levels of parentheses there. This one is tricky because we're not doing a full simplification. And we actually did worse on number 4. We're simply taking it down one step. So we need to do this 1.7. So this is really asking, do our kids know how to multiply decimals? 2.3. So that's 21. That's 51. And that's going to be 34. So that's going to be 391. I've got 2 digits behind the decimal. So 2 digits behind the decimal, 3.91. So this becomes 3.91. I'm doing this first because within the brackets, it's inside the parentheses, and parentheses always comes first. Well, this is it. Look, that's literally the only thing we had to do. We had to match this up. But I think this kind of messed some students up because they were probably going all the way down, and then they realized, oh, I got to back up. I only need to do one step. All right, so we only had 49% on that one. So 26% of our students on number 4 chose A. So let's go back and look at A, right? So actually it's B, should say B there. So when they ignore the first bracket, that means they didn't really know what to do here. And they just ignored it. 6 times 2 is 12. And they didn't realize you had to collapse this entire bracket first. So that's what makes that one tricky is we had a lot of students, they're good with the parentheses, but they might struggle with the bracket. And that one didn't require full simplification. They simply had to do one step. But they both involve 2 levels of parentheses. So our students need lots of practice with both parentheses and brackets. So we need to reiterate the relationship between the brackets and parentheses. Make sure that we deal with these first and these second. And then have them match expressions with partially simplified versions. That might have thrown a few kids off. Not simplifying all the way, but just simplifying partially and then matching that. That could be an extension for some of our students. 5.3E, we had 54% overall mastery. This is reporting category 2. And we need to solve for products of decimals to hundredths, straight multiplication. 1.12, 1.5, right, so that's 10, 6, and that's 5. And then the next row is just by 1, so I'm just going to copy that down. And that's going to be 1, 6, 8, 0, 1, 2, 3 digits behind the decimal, so 1, 2, 3 digits behind the decimal. My answer here is A. And it was straight computation. 27% of our students chose D. Look at D. 16.8. Look how close that is to here. They did the multiplication correct. What they struggled with was where to place that decimal. They put it in the wrong spot. Now, we could have used compatible numbers to estimate, right? So it was 1.5 times 1.12. Well, if I change my 1.12 to 1, then 1.5 times 1 is 1.5. So I needed to find an answer near 1.5, and that would have been my first red flag of, oh, I must have done something wrong because I'm supposed to find something near 1.5. 1.68 is near 1.5. 16.8 is not. And some students might have benefited from an area model rather than straight algorithm. That area model could have helped them keep the decimal places together. And of course, they would have had added up at the end, but that might be something that they could benefit from. 5.4c, we are looking at reporting category 2, 56% overall mastery. And we are generating a numerical pattern when given a rule. So on number 14, we've only got 40% correct here. X plus 4.5. Okay, so we need x plus 4.5. And if we just take our xy values here, right, like we've got 1 and 2. So if x is 1, then y has got to be 4.5 more. So should be 5.5. And that's incorrect. If x is 2, y should be 4.5 more, 6.5. So A is incorrect. Let's check B. If x is 0, then it's 5.5 more, 4.5 more. That's fine. And then I've got my 1, but you see how my 1 went to 9. So B is partially correct. C, I've got my 1, 5.5. That's good. I've got a 3. Plus 4.5 is going to make 7.5. Okay, so we're good with C. And on this one, y equals 6x. So I'm just going to flip this around. Watch this. I'm going to make 6x equals y. So 6 times x. So 6 times 6 is going to make 36. 6 times what makes 60? 6 times 10 makes 60. 6 times what makes 72? That's 12. And then 6 times 20 is 120. So these are my 4 answers here. We had 63% get full credit. 63% of our students got all 4 of those correct. That's fantastic. Partial credit is 3 or 2 correct. So 17%. So we did really well on the table. We struggled with the graph. And the graph did show an additive pattern. A lot of times when we do graphs, we end up doing a multiplicative pattern. So we need to have ample opportunity to translate our knowledge of between all four versions, equations, graphs, tables, and sometimes they'll even put it in words. And it's a verbal description that they've got to understand here. And students need both have to graph both an additive and a multiplicative equation on the same graph. Have them note the difference. So have them do both and notice how different, how much it scales, right? They'll easily be able to see the difference if they put both of those on there together. And then finally, we're looking at 5.4H, reporting category 3. This is 56% overall mastery, representing solving problems related to perimeter and or area related to volume. So 24 cubic meters, we're just multiplying here, right? And this is, look at these, 8 plus 8 plus 8, 9 plus 5 plus 10, 8 plus 10 plus 6. These 3 are incorrect because you're adding. All we're needing to do is check the 2 that you multiply the 3. Except it didn't trick our kids. 77% got both of those correct. 6% got just one of them correct. So that's fantastic. The issue here was number 24. And here we go. Here is our traditional setup. You've got a rectangle that's not pictured. The perimeter equals 320, and they give us the width. What's the length? Well, let's visualize this as a strip diagram. All right, my perimeter is the whole thing. That's my total, 320. What are my parts? Well, I know there's 4 parts, right? I've got the width, I've got the width, I've got the length, and I've got the length. They gave me the width as 70. So I've got 2 70s down there. So what is that? That's 140. So then what is this? I've got my 320 minus the 140. It's going to be 180. So the answer is not 180. The answer is I need to split my 180 between these two lengths. So what plus what makes 180? That's the 90, but that's hard. That is hard for students. We had 32% get that correct. They had little difficulty with multiple select. More students chose A, 48%, 250. That wasn't even close. They just did the 320 minus 70. They just subtracted the two numbers they saw, which means they really had no idea how to set it up. And so this type of problem, right, for number 24, perimeter with one side length, no visual, is seen in third grade. We've seen it in fourth grade, and now it's in fifth grade. They're asking the same question 3 years in a row. So they need to draw a representation to visualize the problem, like I did here. I drew my rectangle, I put my perimeter, and I labeled one side as 70. But once we do that, the next representation we need is that strip diagram. Once we see the strip diagram, break it up into 4 parts, that kind of gives our students a scaffold to start thinking about what are these two missing parts. They can figure that out if they can turn that into a strip diagram.